Hello YouTube. So this is Devroy Davis for Devroy Davis International, and this is my first tutorial series. This video is going to be on just an introduction to who I am, as well as an introduction to what you can expect from my electronics tutorial series. So let's get into it. So who am I? So first things first, first thing you should know about me is that I believe in a higher power, and I'm a follower of Jesus Christ. I am a Christian, and I was baptized into the Church of God faith. I'm a physicist. I hold a Bachelor of Science in Medical Physics and Electronics, and I'm a self-taught programmer. I program proficiently in over 7 languages, spanning anywhere from embedded systems to web development, including backend, so like PHP server side, as well as MySQL. I'm a Japanese enthusiast. No, that doesn't mean I'm an anime enthusiast. It means I'm a Japan enthusiast. So I'm fascinated with their language, their culture. I pretty much just love everything about Japan. And as far as I'm concerned, they're just like the sister country to my home country, which is Jamaica. I'm an investor, so I analyze companies on my local stock exchange, and I purchase shares in different companies as well. I also have a pretty broad interest in terms of business, and you'll learn more about that as you'll pick up more on that as we go on through my tutorials. I like to call myself a personal development student. What that means is basically that I like to just read on trying to become a better person. My focus in terms of personal development is really in career development and wealth and character building. So my ultimate goal, well, first of all, I'd like to be an industry leader. I want to be someone that others can look up to. I definitely want to be a person of integrity, and someone that person can say, I know at least one thing about that guy. He never defaults on his integrity. Like, you can take him at his word. So that's something that I definitely want, and it's something that I'm striving towards. Not there yet. I still tend to be, how do you say, optimistic in terms of deadlines that I might give for certain things. So that's one thing that you shouldn't really be too hard on me for, at least in the beginning stages. But with guys like you to keep me accountable, then you should definitely be seeing that improve over the series. I'd like to be an ultimate investor. What that means is just that I want to build multiple companies as well as take them public. If you've heard the name Robert Kiyosaki or Donald Trump before, then these guys are guys that actually fit in that class of ultimate investors. So they're pretty much guys who own the companies that other investors invest in. So that's where I want to go. One of my dream, it's not even one of my dreams, it's my ultimate dream, is to build and establish a world-class research and development institute in biomedical engineering in Jamaica. I'd like to be the person to actually build the first one, and then for it to attain international acclaim. So that's pretty much it about me. That's a breakdown. So for this tutorial, what we're going to be doing is we're going to be looking into a few things. So this tutorial is going to be based on stuff that I've learned over the years that I've been studying. So we'll be looking into software and hardware electronics design. Some of the software requirements that we'll be looking into, or that we'll be requiring for this video series, are the Atmel Studio, development environment, Eagle software, which is a circuit design software, and Notepad++ for just general code writing. The programming language that we'll be using is C, embedded C in particular. For circuit design, we have different options. So we can choose to use PSpice or Multisim from National Instruments, or my personal favorite, which is Proteus ISYS. The thing is that Proteus is not free. So if you're going to be following along with your circuit designs, while you can draw them on paper, I'd suggest that you get Multisim, which offers a student edition, or Eagle CAD, which also offers a student edition, which you can use to create your circuits. So for this tutorial series, we're going to be using a wide range of hardware tools. We're going to be using prototyping boards or breadboards, and that's this device right here. I'll show you in a subsequent video a walk around of this, as well as its connections and how to connect components like capacitors or LEDs or resistors, as well as connecting wires to it. We'll also be using, in our advanced tutorials, we're going to be using the 80 Mega series microcontroller, which is this device here, as well as 7-segment displays, LCDs, which are not shown here, other dual inline packaging, TTL logic circuitry, and other discrete components. This that you're seeing here is just a simple circuit for use, demonstrating the use of a capacitor. So for this tutorial series, we're going to need to develop some soft skills, and this is really going to form the backbone of these tutorials. These are pretty much the first set of tutorials that I'm going to be building. We're going to learn how to read datasheet of electronic components. We're going to look at how to use a breadboard, as I previously mentioned, and component placement. We're going to look at circuit design, both on paper and in one of the circuit design software that we just mentioned. I might stick with EagleCAD and Multisim. As well as we're going to be looking at converting those circuits into actual physical prototypes. We're going to develop the skill of debugging circuits, and then we're going to look at some best practices for developing circuit prototypes. Okay, so for the actual tutorial series, when we actually begin to get into it, we're going to be looking at discrete components and TTL circuits first. So we'll be looking at resistor and capacitor circuits. We'll be looking at inductors, transistors, both BJTs and FETs, or BJTs and FETs. We're going to look at logic ICs and their applications, and there are a wide array of those. So we'll be seeing quite a few circuits and quite a few applications using those TTL logic ICs that we looked at on the previous slides. And then we're going to look into advanced TTL ICs and advanced circuits. So we'll be looking at multiplexers, LED drivers, we'll be looking at motor drivers, as well as logic level converter ICs, such as the MAX232 and the MAX233. In our advanced tutorials, we will begin looking at microcontroller applications, and we'll be looking at the hardware that we need to program microcontrollers. We'll go through an introduction to embedded programming. We will look at some simple and complex programs, simple and complex applications as well that these programs will actually drive. We'll take a brief look through the 80 Mega series of microcontrollers, and then we'll look at peripherals. So we'll be looking at other devices that we can actually connect and interact with the with the ATmega series microcontrollers. Just as a spoiler, some of these include buttons, LEDs, LCDs, TFTs, motor drivers, as well as some other combinational logic circuits. And then to end the advanced tutorial series, we will look at debugging our C code as well as the circuitry, and then we will again look at some best practices for writing code as well as building microcontroller prototypes. So that's it. I hope to see you in the next video, where we will begin our introduction to the soft skills, the first one being reading data sheets.